In response to market feedback, we also did look at a two-layer solution. The idea of the two-layer solution obviously arose quite early on when there was talk of going to R7 product R value and the roof to achieve a construction R value of 6.6. The obvious early solution was two layers of R3.6, but two layers of R3.6 does pose challenges, both with the first layer being too high for the adjacent truss cords and the second layer also compressing that first layer, reducing its thermal performance. So we developed a unique system for the two-layer solution. The first layer being 110 millimetres thick to go alongside a 90 mm truss cord. So when it sat down on the ceiling battens, which are hung below the truss cords, it sat at the height of the truss cord. And then the second layer, R4.5, went over the top, or we also developed a first layer at R3 at 160 millimetres high for the same reason. So with 140 mm truss cords, it sits neatly in line with the top of those truss cords, so then the second layer can be put on top. The reason that we went to bring R4.5 as a second layer is that when we go to the edge of the perimeter of the roof for the two-layer solution, we actually drop down to a single layer of that R4.5. We don't take the first layer right out to the perimeter of the roof. We actually stop the 110 or 160 millimetre thick insulation about 460 millimetres away from the roof edge, and then we drop to the single layer R4.5. And the reason it is a 4.5, not a 3.6, is because we have a roll panel vent solution which sits underneath the roof line to maintain the air gap between the roof underlay and the insulation, and that compresses the R4.5 down to as little as 115 millimetres high. And under that compression we can actually deliver the required R3.3 construction R value for that roof perimeter with the R4.5 product, which wouldn't be possible with an R3.6.